Hello, my name is Bill Koss. I am the CEO of Jude Technologies. This is a presentation regarding our latest announcement of our fabric architecture. It's really the second generation of our product architecture available in 2024. What we've been building and what we're announcing today is what we call the DynamicXcelerator, or DX Fabric for short. It's really a solution that offers a photonic fabric for scalable GPU to GPU connectivity under software control. What we build at Druid is a complete system architecture from software down through the hardware elements, all connected on a photonic architecture. We believe that the fabric architecture provides a significant differentiation in terms of kind of operating costs, power consumptions, latency, the ability to build direct connectivity for fabric resources that reduce kind of traditional network hop reduction. Our fabric architecture promotes multi-vendor openness. It's really a system level design, attacking what's going to be needed in the kind of large accelerator, AI focused cloud architectures. This is a market we've been working on for a few years. It started initially with us focused on kind of optically connected GPUs, figuring out how to do that technology, and then building step by step across the entire architecture, including a number of cloud suite software stacks at the very top. Our target market is really the emerging, what we call accelerator era clouds, which is much different than the hypervisor era clouds. So these are areas where there's a large amount of GPUs, FPGAs, a heavy concentration of networking equipment, infrastructure equipment, all designed around various kind of LLMs, inference, all these types of things that people are deploying in which they're consuming a large number of GPUs. What we've done, we've gone to attack the problem a little bit differently. We've looked at it in terms of how do we put all these things that you want to put in your modern data center that you currently kind of consume in a server. How do we put those things, disaggregate them, attach them to a photonic fabric, put them under software control, and then allow you to essentially create through software definition composable hardware nodes that have the right mix of resources that are connected based on a connectivity pattern which it best suits the need of the kind of software application that you're using, and not use kind of traditional networking as a scale out connectivity function. So we believe that kind of networks are traditional networks, and we're big believers in networking, big believers in Ethernet, and continuing to use Ethernet as a scale out technology. But that's not the best way to kind of go connect various entities together in terms of resources that you would traditionally find in a boxed server architecture. So we are very much looking to go disaggregate the server, but we don't view disaggregation as a kind of a destination. To us, it's a step along the way. What you need to be able to do is disaggregate the server, break down the components, attach them to a low latency, all optical fabric. And then from there, you need to be able to compose nodes around workloads. So you need to be able to understand what the workload is, impose the connectivity pattern onto the fabric architecture, and thus creating the machine that's best suited for your workload. And this is very different from traditional networking scale out, in which there's a large amount of sprawl. It's hard to tune networks that are kind of built for general purpose connectivity. It's hard to tune them to very specific traffic loads. We believe that it's kind of, traditional methods of networking all the resources you want to put in a data center together is really, exacerbates the problem. And it also causes complexity that wasn't really needed, and a lot of inefficiency and a lot of energy waste, because essentially deploying multiple layers of stacked electrical packet switches. And we believe that we can do a much better job using an all photonic fabric. So today, in summary, the industry is kind of using the same networking technologies, networking methods that we've been deploying for the past 20, perhaps even 30 years. It's kind of a general purpose networking. You got leafs, you got spines, you got cores. You're trying to interconnect all the stuff that's in the racks. We're consuming essentially important resources that we're paying a large amount of money for in kind of a boxed architecture. There's fixed aggregation. It's very hard to tune these networks, very hard to tune this infrastructure to get the efficiencies that you'd like. And all of this when really there is a traffic pattern. There's a workload traffic pattern that we know exists in the world, and we can take that traffic pattern from the actual programs that we're using, and we can imprint that traffic pattern on the network and say, we know this traffic pattern is best for this LLM. Let's use that. And we're really looking at how we kind of go put that together. And we believe when you can have very efficient resource utilization. We can reduce the power consumption. We can remove network hops. We can reduce sprawl. We'll have much lower power consumption, much better thermal profiles, much better lower and consistent latency across the fabric architecture. And all of this will go to kind of reducing stranded resources. And there's another aspect to our solution when you see it. It's just that we believe it is a different operating model. Living with our dynamic accelerator will be much different than the way you've lived with traditional infrastructure consumption